In this video, we're going to talk about multivariate probability, specifically things like E of x, variance of x, and the covariance of x and y. So conceptually, let's say, just to situate some of this, the context here is when you're given the PDF, if you will, of two different variables. So in addition to just x, let's say you know x and y, and you're kind of wondering about jointly how they work. How do they co-vary? As one goes up, does the other go up or down? That sort of thing. But also using a PDF to easily calculate the variance of x. Typically, let's start with that. Let's start with, if you have x, let's say x is a relatively simple variable. It's how many classes you're taking. And let's just say that it's literally just either 2, 3, or 4. People either take 2, 3, or 4 classes. And let's say there's a 50% chance of taking 2 classes, a 40% chance of taking 3 classes, and a 10% chance of taking 4 classes. So if that's the setup, it's pretty straightforward to compute what's E of x. The expected value of x, the expected number of classes, is simply the summation of x times the probability. And that's going to be equal to 2 times 0.5, just multiply them, plus 3 times 0.4, plus 4 times 0.1. So if I plug all that into a calculator, for example, I get 2 times 0.5 plus 3 times 0.4 plus 4 times 0.1, I get 2.6. So 2.6 is the average, which kind of makes sense. Like x is kind of, there's a 50% chance, and so it's kind of averaging between 2, 3, and 4, but there's a lot more weight on 2, so it makes sense that the average here is closer to 2 than it is to 4. But in either case, so that's the average. What if I were to then ask you to calculate the variance of x, v of x? Now, basically, conceptually, first I'm going to show you why this formula is true. The variance of x, the shortcut sort of way to calculate it, is that it's the expected value of x squared minus the expected value of x squared, like this. So it's like when you read it out, it's like expected value of x squared minus the expected value of x squared. But really, it's like the expected value of x squared and then minus the expected value of x squared. So first, let's just say why. Let's see why this is true, and then we'll see how to easily apply it. So the reason why it's true is because conceptually, the variance of x is the average distance from the mean. So v of x is basically the distance from the mean is x minus the average. And so this looks a little confusing at first, but x minus the e of x. But it's like the average of that. So it's literally just the expected value of x minus e of x squared. That's really what it is. It's the expected value of x minus e of x squared. And basically, if you distribute this out, x minus e of x squared, if you just, FOIL out x minus e of x. And, it's probably easier when you're thinking about this to think of e of x as just like the mean, mu. That just makes this notationally a little bit easier. That way there's not a bunch of e's going on. So for now, if we think about e of x as just mu, then the expected value of x minus the mean squared, the average distance, the expected distance from the mean squared, if you FOIL out this guy, that's going to be x squared minus 2x mu plus mu squared. That's just how you do any old a minus b, the whole thing squared. You FOIL that out. And then from here, if we break this down as the expected value of all this, would just be one term at a time. That's the expected value of that first term, x squared, minus the expected value of the second term, 2x mean, plus the expected value of the mean squared. And again, don't worry at this stage really about the details here, but just know that essentially whenever you have a constant, you can pull that out of the expected value thing. So really, it's like if you have this variable x, if you multiply by 2 and the mean, then essentially that's the same thing as, multiplying the expected value of x, e of x, by the 2 times the mean. That's just like pulling out this guy and this guy. And the expected value of a constant is just that constant. So this is just going to be mu squared. And long story short, and again here, this is just if it's of interest to you. Otherwise, if not, then all you really need to know is that how do you calculate the variance of x? It's this last step over here. But basically, you have e of x squared, and when you do this out, e of x we said was mu. So this is really just like minus 2 mu squared plus mu squared. So it's like minus 2 of something plus 1 of that thing is just overall minus 1. And so here you basically get minus e of, well, technically it's like minus mu squared. But then remember, I said mu was literally just e of x at the very beginning. I just said we're going to call e of x as mu. So really all this, if you're technically every mu here should be an e of x if we're being consistent with the notation. So at the end, this was really e of x. I just wrote it as mu so that we don't have a bunch of e's going on. But long story short, this is e of x squared minus e of x squared. So that whole thing that I just did, if this was like, oh yeah, this was interesting, great. If this is like not interesting, don't worry about it. All you need to know, even if none of this made sense, if your math is, not as fresh, then that's okay. All you need to know is this last thing over here, that the variance of x is the expected value of x squared minus the average of x squared. So now applying that here, how can we then find the variance using that formula with this PDF over here? Well, we already know the expected value of x. E of x is 2.6. So that's this guy over here. This e of x is 2.6. So the variance of x, big picture, should be the expected value of x squared. We actually don't know what that is. But then minus e of x, which we know it's 2.6. And then squared. It's e of x squared. So now let's talk finally a little bit about that first term. What is e of x squared? Well, e of x is just the expected value of x. It's just x times the probability. Add them all up. So the expected value of x squared is simply, what if here, if this is x, x squared is simply, if x is 2, x squared is 4. If x is 3, x squared is 3 squared is 9. If x is 4, then x squared is simply 16. So really, the expected value of x squared is just the sum of x squared times its probability. So x squared is 4 with 50% likelihood, because, again, x squared is 4 when x is 2, which happens 50% of the time. 50% of the time, you have 2 classes, and therefore an x squared of 4. 40% of the time, you have 3 classes, and therefore an x squared of 9. And so, long story short here, this would just be 4 times 0.5 plus 9 times 0.4 plus 16 times 0.1. But really, instead of 4, 9, and 16, you could also just think of write these as 2 squared, 3 squared, and 4 squared. Just the x's, 2, 3, and 4. Just square the square of the x's multiplied by those same probabilities that we had earlier, 0.5, 0.4, and 0.1. And so that's really conceptually what this means. And so going back to this guy over here, instead of 2, if we had 4, or 2 squared, instead of 3, we had 9, 3 squared, and instead of 4, we had 16. All this ends up being 7.2, which means that's this e of x squared is 7.2. So finally, the variance of x, v of x, is, e of x squared, which we just calculated as 7.2, minus the e of x, which was 2.6 squared. So 7.2 minus 2.6 squared. So that's just, 7.2 minus 2.6 squared is 0.44. So that's the variance of x here, 0.44. Notice that this number can never be negative. So even though it's like something minus something, if you get a negative, you did it wrong, because conceptually variance is never a negative thing. So yeah, that's how you can find the variance if you're just given a PDF. But you might also be given something about another variable y. So if you have x and y as two different variables, now in addition to finding the variance of x, you can find the covariance of x. So big picture, the covariance of x with another variable y is simply the expected value of x minus its mean times y minus its mean. And when we do the simplifying math over here, I'll skip the algebra this time, but essentially when you FOIL all that out and do what we kind of did over here, that covariance thing simplifies to something very similar. Instead of e of x squared minus e of x squared, it simplifies to e of x times y minus e of x times e of y. So this is the formula we can use to find covariance. So if you're basically given information about x, y, like if you're given e of x and e of y, and also e of xy, well, that's enough information to find the covariance of x with y. And so you would do this. And this, unlike variance, covariance can be positive or negative. So again, here, I won't really do an example here, just because it's really just you'd be given this, this, and this, and you just plug it in here. But conceptually, what this means is if the covariance is positive, if the covariance of x and y is a number greater than 0, then that means overall that as x goes up, y goes up, and as x goes down, y goes down. So it kind of means that they kind of have like this positive correlation, if you will. And on the other hand, the covariance could be negative. If the covariance is negative of x and y is negative, that sort of means that conceptually there's a negative relationship. As one goes up, the other tends to go down. That means that there's a negative relationship there. And the final thing I'll say here is this, is that the variance of x is simply a special case of covariance, actually. So the variance of x is literally just the covariance of x with itself. So that's kind of like saying, how does x vary? Instead of seeing how x varies along with y, like are they a negative relationship? Are they a positive relationship? It's really just like saying, how does x vary with itself? That's really what variance is getting at. But I just want to show you how this works with the formulas, because remember we said that the covariance of x with y is the expected value of x times y minus e of x, the average of x, times the average of y. Here, if I just replaced y with another x, so the covariance, so if we wanted to actually find the variance of x, meaning covariance of x with itself, and we use a covariance formula, but we just replace this x, this y with another x, then this would be the expected value of x. Instead of times y, it'd be x times itself, so x squared, and then this would be e of x, and then this, instead of e of y would also be e of x, so it's really e of x times e of x, so you'd get e of x squared, because there's two of them multiplied, and that's actually the variance formula that we did earlier.